Hello mathematicians, and welcome to the quadratic formula part 2. Now before I get started, I actually wanted to review something that is called the giant one. So you should have this worksheet in front of you, and right here I made a little note section for you. So right here, 12/16, this is a fraction. And when I use the giant one, what I want to do is that I am reducing my fraction. Reducing fractions. So in order for me to be able to reduce this fraction, I need to use the greatest common factor. This is something hopefully that's ringing somewhat out of a bell. So what I'm going to do is I'm going to look at the number 12 and 16. And I'm going to look at what numbers make 12 in terms of multiplying. Only multiplying. So 1 times 12 makes 12. 2 times 6 makes 12. And 3 times 4 makes 12. And that's it. Hopefully you have a multiplication table in front of you if you need it. If not, that's also cool. Now it's 16. 1 and 16 make 16. 2 and 8 make 16. And 4 times 4 makes 16. So these are all called factors, okay? So I'm trying to find the greatest common one. So looking at all these numbers, I'm trying to figure out which is the biggest number that they share. So for example, they share the number 1, they share the number 2, and they share the number 4. I didn't circle the other ones because, for example, 12, there is no 12 down here, so I can't circle that. Now the biggest one that they share was the 4. So that means that my GCF, the greatest one, the biggest one they share is 4. So now what I'm going to do is I'm going to rewrite my numbers using this 4, okay? So 12 is 4 times 3, and 16 is 4 times 4. Now what I see here is that I have a 4 over a 4. And if we remember, 4 divided by 4 is 1. Any number divided by itself is 1. So here I created a giant 1 on purpose, and I can just cross it out. So what I'm left with is 3 over 4. So if I were to draw these fractions up and shade them in, they would look exactly alike. We're going to use this concept today with our formula, okay? So let's start off with this example. I am going to go faster given that we just went over the first part, and hopefully you guys have a better hang of it. So step 1, I have to make sure it's equal to 0, which it is. Second step is I have to identify my A, my B, and my C. I see that my A is 6. My B is an imaginary 1. And my C is a negative 2. Now I'm going to plug it into my formula, which I also provided for you here, just in case you don't remember it yet. And it is x equals negative b, so I'm going to plug in 1, plus or minus the square root, or radical, same thing, of b squared, minus 4 times a, times c, all over 2 times a. Whoops, wrong color. So now I'm going to clean this up. X equals negative times a positive 1 is negative 1, plus or minus the square root. 1 squared is equal to 1 times 1, which is just 1, minus 4, oops, just kidding. I got ahead of myself. So right here I have 4 times 6 times negative 2. So 4 times 6 is, oh, and it's a negative 4, okay? Ooh, you see, sometimes even I make little mistakes when I go too fast. So I'm multiplying. Negative 4 times 6 is negative 24. And now I have to do negative 24 times negative 2. 24 times 2 is 48. And a negative times a negative is a positive. So over here, I'm going to write just that. Plus 48 all over 2 times 6, which is 12. I'm going to clean up this inside of my radical now. X equals negative 1 plus or minus square root 41 plus 48 plus 1 is 49 all over 12. X equals negative 1 plus or minus the square root of 49 is, whoops. So I'm going to hit my base, 49, hit my little square root button, and I get 7. Let me close that, it's getting me confused. 7 all over 12. So now this is when I do my two cases. So I have x equals negative 1 plus 7 over 12. And then I have x equals negative 1 minus 7 over 12. Okay, so I'm going to keep cleaning this up. Negative 1 plus 7 is 6 over 12. But hold up, I can't clean that up. If I do 6 divided by 12, I get a decimal. So that means I'm going to get a fraction. And since I'm going to get a fraction, I'm going to try reducing it as much as I can. So we're going to try reducing. And I'm going to show you how you can take little steps to get there, okay? So I know, let me rewrite this. I see that both of these numbers are even, right? And since they're even, that means that 2 can go into them super easily. So I'm going to rewrite them using 2's. So this is equal to 2 over 2. 2 times 3 gives me 6. And 2 times 2 times 6 gives me 12. So right here I have a giant 1. And I can cross them out. But hold up, can I reduce this even further? They're not even. Well, 6 is even, but not 3 is not. So I can't reduce them by 2. But what about by 3? If I had a multiplication table in front of me, I would see that I could reduce it by 3. So I'm going to take an extra step. 3 and 3. So I know that 3 times 1 gives me 3. And 3 times 2 will give me 6. And I just created another giant 1. Equals 1 over 2. Can I reduce this? I can't because I have a 1 and I have a 2 and both of these numbers are prime. So this is my first answer, 1 over 2. So let's go ahead and try it out with my second one because remember I have two cases. So I'm actually going to go this way. Negative 1 minus 7 gives me negative 8 over 12. And again, if I were to plug this into a calculator, I'm going to get a decimal. So that means that I'm going to have to reduce my fraction, okay? So reducing. So I have x equals negative 8 divided by 12. I'm actually going to move this over a little further over here. So I have some space. So again, both of these numbers are even. So that means that 2 can go into both of these numbers. So I'm going to make my new fraction using 2's. So I know that 2 times -4 will give me a -8. Remember, we have to be careful with our multiplication signs, okay? I mean with our positive, negative signs. And I know that 2 times 6 will give me 12. So I just created another giant 1. So what I'm left with here is -4/6. But hold up, these two numbers are even again. So that means that 2 can go into both of these. So I'm going to make another giant 1. Whoops. So I know that 2 can go into both of these. And I know that 2 times a -2 will give me -4. And I know that 2 times 3 will give me 6. So I just create another giant 1. Now, can I reduce this next fraction? I can't because 2 is prime and 3 is also prime. Anytime I run into 2 prime numbers, I know that I should stop. So that is my second answer. So my answer would be x equals 1/2, comma, -2/3. And that is my final answer. Now, if you got the hang of this, you can go ahead and pause the video here. If not, I'm going to jump onto the back side and do a second problem. So, again, I have to make sure that this is equal to 0. This is not equal to 0. I have to make it equal to 0. This is an imaginary positive. So to get rid of it, I have to do a -x. And what I do to one side, I do to the other side. So x minus x gives me a 0, which is what I wanted. Let me make this a little thicker. And on my left-hand side, I have 6x squared plus 6x minus 6 minus x. Well, I see that with like terms, I'm going to subtract these two together. So I have 6x squared plus 5x minus 6 equals 0. So now I can get started. So identify A, B, and C. A is 6, B is 5, and C is -6. So if I do my quadratic equation, x equals -b, so -5 plus or minus the square root of b squared, so 5 squared, minus 4 times a times c, all over 2 times a. Now I'm going to clean up. X equals -5 plus or minus 5 squared is 5 times 5, which is 25. And this whole mumbo jumbo, I'm going to plug into the calculator. You can also do that. So I have 4, which is a negative, times 6, times another 6, which is negative, and this gives me 144. All over 2 times 6, which is 12. Now I'm going to simplify inside my radical. So I get x equals -5 plus or minus the square root. And I'm going to do 25 plus 144, and that gives me 169 over 12. Next step is I'm going to take my square root. So I'm going to do 169, and I'm going to hit my square root button, and that gives me 13, which is a lot nicer than that radical. 13 over 12. And this is when I get to my two cases. First case, 13 is positive. By the way, it does not matter which order you do the cases. You could have done negative first. It doesn't matter. So I get x is equal to 8 over 12. Now if I were to simplify this, because this is a fraction, and if I plug into the calculator, I'm going to get a decimal. I'm going to try reducing this. I know that 4 can go into both of these. You can do these by 2s to be safe, but I know that 4 goes into both of these numbers. So I'm going to rewrite my fraction using 4s. I know at the top that 4 times 2 gives me 8. And at the bottom, 4 times 3 gives me 12. I have created successfully a giant 1. And I get that this is equal to 2 over 3. And that is my first answer. Let's go ahead and do the second case. X equals negative 5 minus 13 over 12. Negative 5 minus 13 gives me negative 18 over 12. Again, this is a fraction that is not going to reduce into a nice whole number, so I'm going to try reducing it. This time, I'm going to play it safe and go by 2s just to show you get the same answer. So these are both even, so I know that 2 goes into both of these. 2 times 9. Oh, but remember, this is negative 18. Don't forget about that negative. So 2 times negative 9 gives me negative 18. And 2 times 6 will give me 12. I have created a giant 1 here, so I erase this. And I'm left with negative 9 over 6. I know that 3 can go into both 9 and 6. So I can reduce it once more. So 3 and 3. I didn't do 2 because 9 is odd. I know that 3 times negative 3 will give me 9. And 3 times 2 will give me 6. So again, I have created a giant 1. And I am left with negative 3 over 2. And I stop here because 3 is prime and 2 is also prime. This is my second answer. So to end it off, my answer would be x equals 2 over 3 and negative 3 over 2. So that means that on this graph at these points, we have our roots. And that is it. I'll see you for the third and final video. Go ahead and jump onto Delta Math.